Hello everybody, this is Quinn Murphy reviewing problem number 1 on exam 2 as a little bit of a review, study guide, slash whatever anybody in the future needs it to be. So part of test wrapper 2. So I'm going to go ahead and get started and read the question. A point charge is located at the following locations and has the following velocity. Q1 equals 2.5 e to the negative 5 coulombs located at R1, which is negative 430 in vector notation, with velocity 1, 3.5 e to the 5, 1.5 e5 in the y direction, and 0 in the z direction, also in vector form. So it says calculate the magnetic field of Q1 at the origin. So this is a big first step in making sure you get the problem right. You want to do the origin minus the source. So we know the source is the negative 430 vector, and we're going to go ahead and assume that the origin is 0, 0, 0. So if you do that, then your r vector, or your new r vector, which gives you the distance from the observation and source, or observation to the source, is negative 4, 3, and 0. So you want to go ahead and find r hat. So 4 squared plus 3 squared, square root of that is going to be 5. And then you can use that to find your r hat vector. So you should get 0.8, negative 0.6, and 0. And then you're going to go ahead and use the equation. B vector equals mu naught over 4 pi times q times the velocity times the position vector over the magnitude cubed, magnitude of r cubed. So once you go ahead and plug that in, it's important to remind that when you're doing the velocity, or when you take the cross product, I like to do like I, J, K on top, and then the velocity. So it would be 3.5 E5, 1.5 E5, 0, and then down the bottom you have your R vector, so 4, negative 3, and 0. So I do the method where you cover up one letter. So for example, you cover up K and you get 3.5 e to the negative 5 times negative 3 minus 4 times 1.5 e to the negative 5. And so if you work that through, then you get only an answer in the z direction. So the correct answer for that, once you plug in all the numbers, and again, make sure that you do the cross product of velocity and position, so v cross r, before you multiply through by q, and that is negative 3.3 to the negative 8th in the z direction. So that gives you the right part for the first one. And then flipping over, let's see, a positive charge Q2 equals 1.2 e negative 5 coulombs is placed at R2, which is vector 0, negative 1, 0, and is moving in the xz plane with an unknown speed. Calculate the velocity of the vector Q2 so that the net magnetic field at the origin is 0. So the big phrase here that you should catch on to is looking for the net magnetic field, and at the origin is 0. So you want to start with B net, so you assume B net is equal to B1 plus B2, so summing all the B's is equal to 0, just kind of like you would in statics or anything else when you sum up the forces, or in this case we're just summing up B. So again, you want to do the origin minus the vector that they give you, the new position vector, so it should be vector 0, 0, 0 minus 0, negative 1, 0, and then your final r vector is 0, 1, 0. And then you want to go ahead and you have your, you can same r hat values, so just 1, and same with your unit vector. So then you're going to go ahead and find B2, and you're going to use that same mu naught over 4 pi times Q2 times V2 over R2 squared, and you can rearrange that to find V2. So you get the value 2.75 e to the 4th meters per second, and then because you know that you want your final answer to be in the z direction, you know that when you have to take the cross product, that this value of V2 actually has to be in the x direction. So the correct answer will be vector notation 2.75 e to the 4, comma 0, comma 0, closed vector, and that is your final answer. So thank you very much.